Hello again. Here we are back with the segment addition postulate. Sounds a lot tougher than it is. So remember, the way that we remember it is just part plus part equals whole thing. So first thing we're going to do in just about every geometry problem, especially one that has a diagram with it, is we're going to look at the given information and we're going to label the picture. So right now they're telling us df. That's the whole thing. That's the length of the entire segment is 27, and then EF is 11, and they want me to find the measurement, find the length of DE. Well, I don't know what it is, so just like in algebra, we could call it X. Now, if you want to write out the whole thing, you could say DE plus EF equals DF. And kind of fill in the information that you know, just like in algebra. DE is X. That's what I'm trying to figure out. EF is 11. And DF is 27. So what does X equal? Well, it's just a one-step equation. X equals 16. Some of you probably didn't need to write out all the steps for algebra because you could just say to yourself, something plus 11 equals 27. What has to go here? Well, couldn't I, just like if part plus part equals whole thing, couldn't I do whole thing minus part equals other part? So couldn't you just do 27 minus 11? And the answer is yes, you could. Things can get a little tougher algebraically, as you'll see in the next example. So here we go. dB, the entire thing, the length of the entire segment is 37. dm is x plus 5. And mb is 6x plus 4. How do we do segment addition postulate? Part plus part equals whole thing. A lot of times, if we just rewind back to the example 5 for a second, a lot of times people assume that x has to be by itself. So a lot of people will do this one and say, oh, 11 plus 27 equals x. That's not the case. No matter where the variables are, part plus part equals whole thing. So again, if you want to write out the letters, you can. Some people like to do that and some people don't. You certainly don't have to. But if you wanted to, it would be dm plus mb equals db. Well, what's dm? X plus 5. What's mb? 6x plus 4. And what's db? 37. Some people are a little bit kind of rusty with algebra, maybe forget how to do this. If you find that you're struggling with any of the algebra, of any of the stuff we're doing in Chapter 1, please come in and see me. I have extra practice problems I can give you with algebra. I used to be an algebra teacher. I can help you out with this stuff. Okay? What we're doing when the x terms, the variable terms, are on the same side of the equation, you're doing what's called combining like terms. So you're not going to subtract x from both sides. You're going to do this. X is the same as if there's a 1 there. 1x plus 6x is 7x. And then you can combine these numerical terms too. 5 plus 4 is 9. Now, once you're doing this, how do I solve for x? You're trying to solve an equation for a variable, so you do the reverse order of operations. SADMAP. You're going this way. So if I have a multiplication and an addition here, I have to do the addition first. How do I undo adding 9? Subtract 9, subtract 9 from both sides. So 7x equals 28. How do I undo timesing by 7? Divide by 7, divide by 7. So x equals 4. Now, look at what the question is asking. This is another thing that happens. People are very used to just solving for x in algebra and then they stop there. Well, sure, I wanted to know x in this. It's 4. But this question also wants to know dm and mb. They don't just want you to find x and move to the next problem. What's dm? dm is x plus 5. So I have to do 4 plus 5. I'm substituting my value of x back in just like you did in algebra. dm is 9. MB, there's two ways you can get this. One of these is you can take the expression for MB, 6x plus 4, and put 4 into it, substituting it in. That's fine. And that'll give you 24 plus 4, which is 28. But another thing you could have done is remember what we said up here. If part plus part equals whole thing, then whole thing minus part equals the other part. So once I know that dm is 9, I say to myself 9 plus what equals 37. I could have just done 37 minus 9 and get the 28. Alright? Now let's try another one here. What I want you to do for number 7 is I want you to label everything and do the work on your own. You know, pause the video now, label everything, do all the work on your own, get the answers, fill them out here, and then unpause it and check with mine and see if you got those. So go ahead and pause now and complete example 7 on your own. I wanted to pick up right here instead of just going right to the answer because this is something else that has given a lot of people problems in the past few years in geometry, so I wanted to kind of revisit that from algebra. So again, label the picture. T is between S and P, so put T here. Label everything. ST is 12, TP is 3x minus 1, SP is 5x plus 1. It's part plus part equals whole, so it's ST plus TP equals SP. That's 12 plus 3x minus 1 equals 5x plus 1. When you're right here, you combine like terms. So there's only one x on the left side, x term, so it's 3x. What's 12 minus 1? 11. So it's 3x plus 11 equals 5x plus 1. When you have variable terms on both sides of the equal sign, you need to get rid of one before you can solve for x. So when I have a 3x and a 5x, I think it's easier to get rid of the smaller one. So I'm going to get rid of 3x. How do I get rid of a positive 3x? I subtract 3x. But if you subtract 3x from the left side of the equation, you have to do the same thing from the right side of the equation. So do that before trying to do SADMAP like we set up here, right? So 3x minus 3x, those just go away. So I have 11 equals 2x plus 1. Now I can do SADMAP. So I have a multiplication and an addition. Got to do the addition first. How do I undo adding 1? Subtract 1, subtract 1. So I have 10 equals 2x. How do I undo timesing by 2? I'm going to divide both sides by 2. So I'm going to get 5 equals x. I am not done with the problem. They want to know not just x, they want to know TP and SP. So I'm going to plug 5 in. I'm going to substitute it into those expressions. So what was TP? TP was 3x minus 1. So it's going to be 3 times 5 minus 1. Now when I'm just evaluating this expression, I'm doing the regular order of operations, which is, if you recall, PEMDAS. So I have to do this multiplication first, 15, then I subtract 1 is 14. Now I'm going to do the same thing with SP, or you could just do part plus part equals whole. Here's what I mean. SP is 5x plus 1. So you can go like this, which is 25 plus 1, which is 26. Or you could say, wait a minute, they want to know SP, which is the entire length. This is 12, TP is 14, part plus part equals whole. What's 12 plus 14? Oh, it's 26. You could do it either way. Alright? So now I want you to do the same thing. I want you to pause it and do example 8 the whole way through, and then I'll have all the answers up for you. Pause now. Okay, so there's all the answers. This one had kind of both of the algebraic problems that I've seen come up in the past when I've taught geometry. One of them is when you have x terms on the same side, you combine like terms. And then the other one is when you have an x on either side of the equation. How do I do that? So really quick, just make sure your setup is the same as mine. O is between D and G. So D and G are on the endpoints. O is in there somewhere, not necessarily in the middle, but somewhere in between. Label. DO is 3x plus 2. OG is 5x minus 3. Whole thing DG, 6x plus 5. If you draw this picture, you make it a lot easier on yourself to at least get some points on a quiz or test. Now, part plus part equals whole. DO plus OG equals DG. Put in the numbers. And now here we are, like I said, at the first algebraic problem that people have had. Combine the like terms. 3x plus 5x is 8x. And 2 minus 3 is negative 1. So I have this equation. 8x minus 1 equals 6x plus 5. Now we run into another thing that gives people a little bit of problems, which is when you have an x term on both sides of the equation. I like to get rid of the smaller one, so I subtracted 6x from both sides. Remember, if this was a negative 6x here, I would have added 6x to both sides to get rid of it, right? Okay, so I have 2x minus 1 equals 5. I'm going to do SADMAP. I'm solving an equation for a variable, so I have to do this first, the subtraction. How do I undo subtracting 1? Add 1 to both sides. Now I have 2x equals 6. Come over here to get more room. How do I undo timesing by 2? Divide by 2. There's 3. Now I need to know the measurements. I need to know the lengths of all of these segments. So I use x for 3, substitute it in. 9 plus 2. Remember, when you're substituting it into just this expression, it's PEMDAS. So I do 3 times 3 is 9 plus 2 is 11. I could do 18 plus 5 here is 23. And then I could do 15 minus 3 is 12. Or you could get DO and OG and add them, because part plus part equals whole. 11 plus 12 equals 23. Okay, we have one other final thing here, a word that is very important in geometry that we're going to use a lot, which is called congruent. Congruent means the same measure. So how do we measure a line segment? Well, we measure this whole thing we've been doing, we're talking about the length, right? The distance between the two endpoints. So segments that have the same, let me draw a little line here to get this. Segments that have the same length are called congruent. It doesn't matter if they're facing the same way or not. Okay? So, look, let's go AB. That doesn't look very good. Let's redo that. Here's one, and here's one. Let's say this is AB, and we're going to call that 5. And this is CD, and that length is 5. And then this is HG, and that length is 5. All of those segments are congruent. It doesn't matter that one is vertical and the other two are horizontal. Here's how we write it, okay? We say AB, segment AB, is congruent to segment DE. So it's an equal sign with a tilde on top of it. This says line segment AB is congruent to line segment DE. So that means that they have the same length. Do you remember how we write the length of line segment AB? We write just the words AB. So this says line segment AB is congruent to line segment DE. This says the length of AB equals the length of DE. If this is true, then this is true, and vice versa, because that's what congruent means. Congruent segments mean they have the same length. So if I tell you AB is line segment AB is congruent to DE, you're supposed to know AB equals DE. If I drew this picture for you, and you look at it and say, oh, AB is 5 and CD is 5, they have the same length, then you would get to say, oh, that means line segment AB is congruent to line segment DE. They have the same length. And that's kind of written for you here. We say the lengths are equal, AB equals DE, but we say the segments are congruent. So don't say the segments are equal. Segments are congruent. And don't say the lengths are congruent. Say the lengths are equal. Again, I would encourage you to go back and study over all of these sections, especially the vocabulary, because if you can learn the vocabulary, it's going to help you out for our first quiz coming up. Okay? Good job.